Good evening. Welcome to the Tiscon eDiscovery webinar series. This is the 19th in the series, and I would like to thank Tiscon to have me for this webinar. It's a fantastic opportunity for architects and engineers to see each other's works and to give critical suggestions. So, I'm talking about sustainable construction for low-rise buildings. I would first like to contextualize this subject. A suggestion for all the attendees is that you will have a lot of questions during this webinar. You can ask these questions, you can keep typing these questions in the window, and I will take these questions once the talk is over. The talk will last around 40 minutes, and we will answer your questions after that. To your left is a typical viewing frame of how architecture and construction has been viewed for a lot of years. This monumental scale of architecture is what we generally prefer to admire, study. Whereas to your right, you have the frame reversed. How would the world look if you reversed, if you went to this monument, turned around and looked down upon the larger built environment? So more than 60% of India's population lives in the buildings in the vernacular tradition. And I have come to study and to work with people living in this kind of built environment more than in the monumental architecture. This is a slide which shows an iron triangle from a book by Ramchandra Guha and Madhav Gadgil. It is a nice triangle to find out where we are amongst these various stakeholders. Are we the urban population? Do we represent the industry? Are we agriculturists? Are we administrators, decision makers? There is this aspect which I believe that architects, engineers, designers should be very conscious of. So wherever we are in this triangle, uh, interestingly, most development and construction happens at the cost of what you see below, which is the subsistence sector, uh, where all the materials come from, where all the workers come from, also where all the waste of our field building industry is disposed. All the resource comes from this area. I would like to contextualize the situation today that still, this is a 2011 census data. Even in 2030, almost 60% of India will still be in rural areas. So I wonder whether architects and engineers are thinking enough about the rural population, their built environment, also about how India is getting urbanized and where is more need for designing buildings. This graph explains to you how in the last 30 years we have built around 20 billion square meters of buildings, and in the next 10 years we are going to build the same 20 billion square meters. So what is the quantum, what is the scale and the speed at which we are going to be building in the next 10 years? And who are our beneficiaries? Who are the stakeholders? Where is the major building going to happen? And my argument is that it is not in the big metropolis cities. It is in the tier 2, tier 3 cities and in the rural countryside. This is to just take stock of what are the materials that our industry majorly uses. And we all know that coal is an extremely inefficient source of energy. And what are the major industrial consumers of coal? It is our building industry. You have steel, you have burnt bricks, and you have cement. That majorly consumes coal in this industry. Here is a statistic to discuss how the use of materials for the roofs in our country, which are the major kind of shelter elements in a building, what are the materials which are being used in a decade? So you can clearly see how the use of concrete is increasing, use of asbestos is increasing. Now all these materials are extremely expensive. Not only are they thermally inefficient, which is they make the space hot, also they cost a lot. So it is very interesting how what are the choices the people are making or the industry is making for the built environment. This is to understand what materials are being used in the walls. In India, even today, 19% of walls, which is 20%, which is 1/5 of walls in India, are being made with unburnt brick, and 37% is brick. So it is a very interesting area to understand what is the choice and what is the major material being used in the walling systems in India. Now this brings attention to a collateral aspect of, say, a material which we choose to build with. The burnt brick sector causes this kind of distress migration for various stages of making bricks. So you have migration of people who mold the bricks, you have migration of people who fire the bricks, and then you have migration of people who load and unload the bricks. So this causes so much distress in the countryside, in the people and the human resource of this country. It is important to see what we can do, and I will address some of these issues in my practice. The slides you will see are about sustainable building, and when I say sustainable, they also mean economy at a national level. They also mean efficiency at a social level, and then the building can address a lot of other things, including thermal comfort and cost. This explains again how the use of materials has changed in just one decade. Now you are seeing a project I had done in 2004. This house is in Mumbai, and it displays the construction techniques which I have learned from Bakerji, from Laurie Baker in Kerala. I worked with Costford, which is the organization in which Laurie Baker was heading it. And I worked with Costford where I learned these techniques and I brought that to Mumbai. This was the first such house in Mumbai. What will stand out over here is to see that in a place like Mumbai, which has high rainfall, the walls are not plastered. Besides, if you look at the roof, you will see the slab. It's an RCC slab, which has these filler materials, which are basically double Mangalore tiles, Mangalore pattern roofing tiles, kept one above the other and occupying the lower part of the slab. This is how the house looks from inside. There is no plaster whatsoever, even from inside. Even the paint is lime. I will explain the repercussions of all these technologies. This is the way in which the filler slab is made. If you see, it's like any other conventional RCC slab. Only in the lower part where there is a tensile stress, unnecessary concrete is prevented from falling in the lower part of the slab. And we replace it with filler material like Mangalore tiles or any other clay tiles. You could use any other fillers if you want. You can see in this drawing the grid of steel, the reinforcement grid. The center to center between the steel bars is extremely high, whereas in your conventional slabs you go with a center to center of 15 centimeters by 15 centimeters. Here you have almost 30 centimeters by 45 centimeters or 50 centimeters. So this distance between steel bars increases, so you use almost 20% lesser steel, and all that space in the lower half of the slab is occupied by a filler material like clay tiles. So around 35 to 40% of concrete is reduced. You have a lot of benefits of this technique. What you get is a lighter slab, a leaner slab. You consume less concrete, less steel, so you save a lot of money. You also save a lot of embodied energy and pollution. Besides, the inside of the house is cooler because of your double layered Mangalore tiles. They prevent the heat from coming in. You can see that slab in the distance where the roof has Mangalore pattern tiles. Now the same technology is used where I had to do a RCC slab in Baroda. This house in Baroda also has the same filler slab and the Mangalore tiles or clay tiles in the roof, but all the walls in this building are made with lime. We replaced the cement in the walls with lime because lime was easily available near Baroda. So, and this house has an interesting detail where below the plinth it is an RCC framed building because it had some black cotton soil. You can see it has a lake nearby, so there was moisture content, and the black cotton soil expands a lot, so it's extremely dangerous to build a load bearing building there. So it's an RCC framed building below the plinth, and above it it's a load bearing building with RCC filler slab, but no columns and beams. That's the drawing of the plan and the section of the building. And you have a courtyard in the center which cools the house because of the evaporative cooling and the breeze which circulates in the entire house. You also have a rainwater harvesting pond below where you collect all the water from the roof. That's how the courtyard looks. And you have a pipe coming down from the roof which connects it down. Now here's a house in New Bombay, uh, in a place which was designed by Charles Correa, an entire colony, but it has lived its life, and now people are breaking those houses. It's quite old, and they're making new buildings, and it is called Artist Village. So a lot of buildings are coming up which no longer look like it's an artist village. They are in RCC, but they have a completely different kind of a look which does not reflect that artists live here. So I got this opportunity to do a house in a very tight plot. Most plots in that colony are tight. So space was very, very important to conserve. So we made an RCC framed building. And we did not plaster the walls once again because it's not required. And if you see on the first floor where there is a higher wind velocity and the rains do hit the wall, we have plastered the wall up to 3 feet height to protect the walls from the rain. But everything else is unplastered. Another interesting thing we did here is, of course, with the help of the structural engineer, Mr. Suhas Chande, we kept the beams only 6 inches thick. Because the walls are only 4.5 inches thick. So why have the beams 9 inches? So we saved on a lot of concrete and steel like that for a lightweight building, and the slab, like the earlier projects, is also a filler slab. That's the same project. Now here is a project where I had worked as a consultant on technology. This was designed by architect Trupti Jadhav. It's near on the way to Pune from Mumbai, and it is Madhav Bagh, which is a Ayurvedic heart care center. So the stress was to make the whole project with natural materials, and I was almost a technical consultant on this project. This is the treatment center. So in this project, again, you see that there is no steel or concrete used. Now here's a building in Goa where I again took the cement out of the walls. Now interestingly, this was the first time I made the walls with mud mortar. It has an RCC roof, a RCC filler slab roof with Mangalore tiles on top of it for cooling and for preventing leakages. and it has mud mortar in the entire walls. The walls are made from local laterite stone because that is available there, but there is no column or beam in this. You will also see this interesting cantilevered windows which are coming out. These are also made completely as a load bearing thing. There is no RCC frame used over here. This is how they are constructed. So just those windows, which are now called bay windows, again something which Laurie Baker made famous, are places where it is a window, but you can also sit, or a child could even sleep in that. So the rest of the house is in laterite stone, but just those windows, because we don't want to waste too much material space, just those windows are made in brick. So beams were replaced with arches. So we did not have to make RCC beams here, although the slab is RCC. We made arches. Now, close to Goa, there is another project just before we reach Goa. It's in Kodal. This entire building, around 6,500 square feet, ground plus one, is made without any cement or steel, and it is facing 180 degrees seashore, has very strong winds, but has dealt with the recent cyclones, etc. very well. This is a photograph from a drone when the construction was still happening. This is how it is from the first floor. The entire floor is made in timber. The roof is made in timber. The walls are made with laterite, but entirely in mud mortar. And the pointing you see is with lime. Here you can see some of the walls which are made completely in mud. And this technique is a local technique. So it is not like we wanted to do it in mud and we got someone from outside to do it. So here I will share a point where wherever we go, wherever we work, we only use local craftspersons to make those buildings. Also, another principle which I've learned from Bakerji is that we only use local materials. Yes, sometimes we have to get some materials from outside, but our stress is to use only local materials wherever possible. So, and the technique is also completely local, of making mud walls. And then we finished these mud walls with mud plaster. Also, the painting made on this mud plaster is by local artists, and the ideas, the designs and patterns are also theirs. Now this is another house. This is closer to Mumbai, and it is in Kamshet, which is a higher altitude area near to Lonavala. Therefore, you will see the walls which are made up to a height of 8 to 9 feet. From outside, you will see stone used in these walls. Again, this is a building which has used no cement or steel from the foundation. Even the masonry in the foundation has mud mortar, not even lime. It is entirely built in mud mortar, and we are just pointing the joints from outside with lime. So it's an extremely cool building. Plus, it learns from the local traditions of building with stone from the outside and brick from inside. Also, the building is made completely by the local people. You see a model of the building kept there to explain to you how we actually communicate with the local workers. Uh, the local workers may not actually be able to read our drawings, which we really learn as a technique to design and to represent from our colleges, but they don't understand these drawings very well. But when we make a model, it is very, very clear to them, and they just scale it, and they can prepare the building very well. This is how the building looks from the other side. It faces a river, so this is an entire veranda which faces the river. This is the space from the inside. You can see it is made in timber. The roof, the first floor is also in timber, the roof is in timber, and we have used terracotta tiles as in the floor, which are extremely cool, and they are not glazed and not overly processed, so you get the benefit of cooling even from the floor. Besides, they are very good for people who may have the tendency to slip, like elderly people or children. They will not get hurt on this floor. That is the veranda of the same house looking at the river. And you can see the combination of stone and brick over here, entirely built with mud mortar and finished with lime plaster. That's the view from the veranda. I must share here that in most of these projects, we have a lot of cooperation and support from the clients themselves, because these projects always, initially invite some kind of skepticism from the locals around, where they feel that, oh, who is this person building this house in mud? Because now even the villagers are not building in mud. So the clients support us a lot, and they believe in what we are doing, and they just ignore all these things. And the result is that after it is built, all the accolades and all the appreciation goes to the clients, because people come and look at these houses and just kind of shower them with a lot of praise, and they deserve all of it because they have supported the designers through the times when people are questioning them. So this is an example of how the arches which you saw in this house were built. You can see that it's completely being made with mud mortar. The support system is made first, and then the arch is put on it, and then immediately the support is removed as soon as the arch is loaded. And you will also notice one thing here, that the people working on this are architects and masons and helpers. So we also believe in, breaking the borders between these kind of uh, you know uh, types of workers, where I believe an architect has to work as a mason, has to go down to the level to pick up the materials and work, so that one can design with a greater knowledge of the construction. So that is why also I feel this webinar is a very good series, where it brings engineers, architects and constructors together. So I believe there has to be a lot of cross-disciplinary learning, and architects must definitely step down from their pedestal and learn from people who actually build. That's the result of this process. The finished arches, completely made in mud right from foundation. This is a car porch. That's the first floor of the same building. It's an attic where there are a lot of sleeping spaces. And this project is now a commercial project, where because it really looked nice, the owner decided to give it out as a weekend getaway place, and they are getting very good reviews for this. That's again the first floor of this same building looking out into the valley. Well, because of the success of this house, the client has commissioned another place which is coming up right next to it. So what you see to the far right is the first house, and this is the new house which we thought we should show. Uh, Looking, it's a different language, but that's because of the limited width we had to develop it. Uh, it was a narrower space. So this is also to show how we make a lot of hand drawings. We visualize the projects in 3D by drawing and making models. This is that second building. That's the plan of it. You can see it's a very linear plan, which is why the language of arches was used. All the arches flowing in the direction of the building. And this is how it is turning out. This project is still not complete, but we thought it is definitely worth sharing. There you go. That's the half arch which we did in this project. This is another project closer to Mumbai, near Khopoli, where again this project has been built entirely from the foundation to the roof in mud mortar, stone in the foundation and plinth, and bricks above that, and a timber roof. That's where you get to see the planning, the model for construction, how we design the openings to facilitate cross ventilation. Every room has cross ventilation, so there are two windows and one wall in any room goes to the toilet. One is for the entrance, and two walls have windows. And there's a veranda, which is largely the social space of the house. That is the veranda. For those who joined in late, let me remind you that you can type in your questions and we will take it by the end of the webinar. All this is done by local craftsperson from around that area. The timber is local. For the finishing, we do use sometimes professionals from the city for the tiling or something like that. But the whole building is mainly built by local people. All the plaster you see in this is also of lime plaster. In most all the three buildings which you saw, that's my recent work. We also plaster the buildings with lime. This is how you see another aspect of this building, that half of it is framed, where there is the living, dining areas and the veranda areas. That much of the building is framed in timber, whereas the other half, which has bedrooms, is more closed. It has brick walls, so it's load bearing. This is the living area, and you see a staircase which we did in timber. It's a single stringer, central stringer staircase we did in timber. Very interestingly, this staircase was made with the leftover wood, since it was the last part we were going to build in the house. It was made by the wood leftover from the roof work. So they are different parts of the roof basically. So your railing, your balusters are all parts, or the battens of the roof, and floor of each step are basically the common rafters of the roof. In the same tradition, it's a ground plus one building, which is again built without cement and steel in the mortar. We have used cement always for the tiling and waterproofing in the bathrooms, but everything else is so these buildings are extremely cool. This owner told us that people actually visit this house, in the summer, guests visit, and they leave the house thinking that the AC has been installed, because that is the kind of temperature difference you get. He reported he actually checked it once in summer, and the difference was almost 8 degrees. These arches are also made in mud mortar with lime pointing. Here you see drawings of the building. You can see the cross section. The central core is a square core. You can see the plan also, and it has verandas abutting from both sides. You can see a detail to your top left of the brackets to hold the overhangs. The overhangs of the roofs are an absolutely key aspect of all our buildings, because they protect the walls from the solar radiation and from rains. You see a construction of a bay window in this house. You will see that below the seat there is an opening in the bay window. So that opening in the bay window actually takes air in when the windows are also shut. Suppose in the monsoon the windows are shut, your house will not become stuffy, because these windows below the seat actually can be operated by your foot. They are pivoted windows, and you can have the cool breeze coming in into the house. That's how the arches, the space between the living and the dining works like this: living, dining and kitchen, and it's a ground plus one arch made in mud mortar. and you can see the tall roof going up, because of which uh, it remains extremely cool. Another strategy which we use is the roofing. So you see to your top left, the roofing has a double layer of tiles. There's the top layer, which is a typical Mangalore pattern tile, and you have a lower layer which is a under tile, because of which there is an air gap in the roof, and the house remains extremely cool. That is where you get to see the under tile more clearly. You can also see the light sources which you have kept in the roof, and the air vents, because of which the hot air rises and goes out. You will also notice that the walls are not plastered, they are just painted in lime, which keeps it extremely cool. Lime also has many other benefits. It keeps the house safe from termites. It also has good seismic properties, where it does not crack like cement does due to extreme changes in temperature. That's another house in the same tradition. It is in Karzat. Uh, Again, a house which is half framed and half load bearing. So you can see the right half is entirely load bearing, and your left half, which has the veranda, living, dining areas, are all framed. And in the center, you have a double height space for interaction and to get the hot air up. That's your central double height space, and you can see the wind direction from west to east. This is how the central space rises up. You can see the whole framed part of it. The load bearing part is to the right. The left side is the entire framed building, which has timber frames. Here we have also used some steel columns, because we have sited the water tank within the building. If you see the top central area, that is the water tank. So in the center, we took two steel columns to be able to make a floor above to take the water tank. This is how you see the double height space in the distance. Going up, you see a timber staircase. You see the walls not plastered, painted in lime. You see bamboo chicks for partitions. That is a bedroom. You see the wooden floor, the wooden roof, and the bay window. Here we have also made the bay window in wood, and you see the openings below the window, which allow this constant kind of cool air coming in. So that bay window also becomes an added single bed sleeping space. Now I'll show you some projects which I've done more in the rural countryside, but for farmers or for people who live more closer to the village life. Here is this is the house for the Deshpande family in Wardha, and they are a family which used to live in the city but moved to the village to live on an agricultural life and with village industries. So this house has been built using the local traditions and working with the local craftspersons. Wardha and that entire area, the Vidarbha, is known for black cotton soil, which is extremely dangerous as a building soil. So the techniques which people have developed there over hundreds of years is what I have used. Here you can see the entire shape of the building. It's a traditional shape, the same as which is used in Gandhiji's ashram also, Sevagram ashram there. You see the cross section of the building where you have uh, the central core, which is a almost 16 feet high central core, which has a mezzanine and a loft. You can see the roof, which is made in wood, but which has bamboo as the boarding. And you can see the right corner where the entire all the layers of materials which are there above that roof are there. This is to reduce the temperature intake of the building, but also to prevent the roof tiles from cracking when the monkeys who come into this area because there is farmland will jump on the roofs. So details have been developed keeping in mind a lot of real problems which people face. You can see how the wall thickness reduces from bottom to top. This has been built with the cob technique. To your bottom left, you can see how the lintel of the window has been designed, where a bamboo meshwork is used to basically act as the distributing tensile member above the entire window lintel. Here you see how the wall is being made. It's around 3 feet thick at the base and it keeps reducing. The topmost layer you see is a fresh layer of mud. These are local people, and the bottom layers are drying. So as they dry, you make a layer, you let it dry, and then you put the next layer above it. There are a lot of natural ingredients which are put apart from the mud. There is straw, there is a bit of lime, and some other vegetable juices. This is the roof, 16 feet tall, with the bamboo boarding above the roof. This place is almost the hottest part of the country. In summers, it goes up to 48 degrees. So this building is extremely cool. Even in summers, you have to take a blanket in the night. That's how you have a kitchen in that corner, and the kitchen is opening into a dining space. You can see the walls finished with mud plaster. The dining space is on the ground, true to local tradition. This is a project in MP where we had helped a local NGO to basically expand their hostel space. So there were spaces between rooms like this. You had this kind of squarish spaces, and they wanted to cover it, they wanted to roof it so that they could add a classroom. It was not above this space. This has trees, but there were other spaces. So it was the people in charge of this NGO were very eager to experiment with different kind of fillers in the slab. So there you see we had made a slab, and they had also, apart from bricks, which was locally available as filler, they've also tried a lot of other materials. That's another project in Madhya Pradesh. This is a school which was conceived and developed by Professor Chetan Solanki, who is head of photovoltaic department in IIT Bombay. This entire roof for this project is done in filler slab, which was basically worked out and constructed by me. Here you see a project in Maharashtra near Karzat, where this was a tribal community house uh, made with an NGO who basically promotes sustainable living and natural farming, and interacts with the local community. So the patterns of the design, the layout of the building is completely inspired by the tribal house plan, so that they can construct it themselves. This house was constructed by the tribal people and people who are from the NGO, also people visiting from all over the world who generally visit this place to learn about farming, etc. So it was made in a collaborative way. So our input was to be very minimal with our design drawings, etc., so that people can build it very easily. So this is when the house was complete. We did a puja. Again, needless to say, there is no cement or steel in this building, and those trees, that all that wood which you see in this house were trees just 2 months before this house was built. So we made a model which you see to the bottom left, like this, with sticks, and the builders there, the local people, just had to measure the scalable members of this roof and had to take down a tree and to build it. So the lowest embodied energy project, because the resources were right behind there, and also these are the people who protect their forests and trees, so they have the ethical rights to use it. They regenerate the forest, so all the materials from the forest are theirs to use. If you can see that in the plan, there is a part of the building which is closed, which are the storerooms, the kitchen, and a small bed area, and the remaining building is completely open and framed. To the bottom right, you will see that there is a technique where we have made the walls of mud, just a 9-inch thick mud wall with brick piers at every 7 to 8 feet and tied with kadapa slabs, which are later going to act as shells, but also while constructing they add as stiffeners for the wall. This is how the roof works out. All local timber and treated with the local preservatives. They make a kind of concoction of the mahua flowers, which is abundant in a season, and then they basically paint it with that. Then that's excellent preservative. This is the walls being made. You see the slabs which later act as storage, but while construction act as stiffeners. And in between it is only mud, the cob technique, but which you saw in Vidarbh in the Varda project, it was 3 feet thick, but here because of this specific design, they are just 9 inches thick. This is the image of the workshop where we were explaining to all the visitors from different parts of the world and from within Bombay or near Bombay also about how this house is going to be built. The model was being explained to them, and this is of course the after party once we build the house. This is a project in Palghar where this is a house which we actually salvaged. Uh, this was a dilapidated house which the owners had really left to decay, and we just requested them if we could take parts of the house. So we struck a deal and they gave us a lot of timber for that from that house, and we built this house, which if you see again looks pretty much like the original prototype. So we made the same tribal plan into a house which could be useful for a person who is going to do natural farming over here, and also had a plan to partly give it out as a weekend getaway. So this is a typical veranda at the entrance of a house of a tribal person in that area. What you see in the center is a closed core area, and beyond you see another veranda like this. So the light really travels through and through. Here you see to your left the typical houses in that area, the house plans and how they are constructed. In the center bottom you see a wattle and daub wall, and just above that you see a brick wall. And to the right you see a cross section of the house which I have built. So it has the same pattern, but it adapts it for urban use, or for a use for a person who's moving from an urban setup to this village. He also wanted, the owner of this house also wanted this house to look like a local house. He did not want it to stand out at all. So due credit to the owner of this house. That is the plan, adapted plan of the tribal house. That's the section, and this is a model. This is how the space looks from within. An interesting thing we did here is, of course, the workers were all from the surrounding locality. The walls are made with unburnt brick. The client was, of course, extremely supportive of the idea, and we wanted to use unburnt brick because we had an understanding that they are strong enough for this design of building, but we thought that it would at once liberate the locals from the need to work all their lives and earn money to make a burnt brick house, which is really a status symbol over there. And from the earlier slides which I had shown you, there's so much distress migration, and so many people really leave their homes to go and work in brick kilns. But if they could make a house with unburnt brick, which they can do at home itself, then it liberates them from a lot of lifelong almost poverty and bonded labor. So this was an idea of doing this, and it is extremely successful. The toilet of this house has a system which conserves water. To the left, you see in the center there is a cold water storage, like a traditional house in Indian villages. And in the corner, bottom corner, you see is basically a water heating installation for which you put the fuel, which is waste wood from the land itself, from outside, so that you light the fire from outside, the smoke remains out, no smoke comes inside the house. But if you want hot water, you can basically just open the lid from inside and take the hot water and pour it into the bucket as much as you need, and the remaining cold water you can take from the house. So that is an interesting thing which we developed at the client's insistence actually. You can see that there is a glass tile in the roof and no artificial light is required. You can see that the roof has a double tile here again, and that keeps it extremely cool. The flooring is a terracotta floor. You see the dining is placed in a veranda, and the kitchen and dining are like this. So it's an extremely open, interactive space and very, very well lit and aired. That's your bedroom. These are the bedrooms which are made of brick walls. The basically the load bearing part. You can see that the beds are also inbuilt. So there's very low maintenance. You can see the bay window, which adds like another sleeping space. But these beds do not have windows because this is a wonderful experience. And it's just the local carvey has been used to make blinds, and people love to use these bedrooms. Coming towards the end of my presentation, this is just to show an aspect of how I have also been sharing uh, my knowledge through workshops with architecture and engineering students. I take them out to site where actual work is happening, or in their institutions, I conduct these hands-on workshops where we actually involve them in making things uh, and also in breaking things. Because once they have stood on an arch which they just made and loaded it enough till it breaks, they come to know what is the running meter UDL an arch like this can take, which is the more important part of this whole exercise. To the left, you see architects preparing the mud for the mortar which is used in the arch to the right. And finally, the other aspect of our practice where we believe that, like I said earlier, that we want to blur the line between architects, engineers, and masons and workers, is our real teachers are these masons, from with whom we have worked and learned more than we have learned in, dare I say, in the libraries and in colleges. The greatest pleasure is when these team members actually take forward ideas, design ideas, and actually use it in their own houses. So you see a bay window there, which without our knowledge, when they were building their own house, they incorporated a bay window in their house where you see the entire thing. The openings below the seat are also there for cross ventilation. You see the photograph from inside the house and from outside the house. So for us, this is a huge aspect or parameter of success, where we can influence or we can actually share interesting building systems with all sections of society. So with this, I close my presentation, and I request you, those who have not already put in their questions, please put in your questions and we will answer them as well as we can for the remaining 10 odd minutes. Great. So I will start answering as many as I can. There are a lot of them, so I'm sorry if I can't answer all. So there's a question of what are the components of the mud plaster. Well, in many places you can just use mud. You don't need to add anything else. But depending on the uh, after field testing the mud, if you need say to add some lime to it, because there's a proportion of how sandy and how clayey it should be, and different places have different mud. So you need to just maintain that balance. So if you need to add some sand to it, or you need to add some sticky component to it, you can add it, and absolutely any place can be built with using mud mortar by adjusting this combination a little bit. You can add around 2 to 3% of lime to mud. Adding cement is avoidable because it does not work as well with mud. But adding that 2 to 3% lime improves its resistance to termites, and also adds a little bit of water resistance. So another question is how to actually treat timber on site. So there are many ways. Firstly, you select timber correctly. You have to make sure it is air seasoned when you buy it, when you order it, the logs you get cut, you must make sure that it is well seasoned wood. Secondly, you can use many natural preservatives. We use linseed oil in areas where we get that, but if we are close to the coastal sides where cashew is growing, we use cashew oil. And there are different treatments for different regions. So, of course, if you have a very specific project, you can get it seasoned from a proper seasoning mill. Forest Research Institute, Dehradun is one of the best places for that in the country. Why mud is used in place of cement? Well, cement uses a lot of embodied energy. It is extremely polluting in the entire manufacturing process. After you make a cement building, when you have to break it down and throw it away, it will pollute the land where you throw the cement. It also causes a lot of health problems. It is very expensive. It makes the building extremely hot. Also, you must just answer this question to yourself. What happens if you plaster your clay pot in which you store water with cement? Will that water afterwards also be cool? You will get my answer for why use mud in place of cement. So your buildings are just like your mud pots or mudkas. You want to avoid really plastering it with cement. So many of the slabs which I have shown you are made of RCC. But in that RCC slab, we are using fillers so that we reduce the amount of concrete from the tensile stress zone of the concrete slab. So if you have a 5-inch or 6-inch thick concrete slab, the lower 2.5 inches is a tensile stress zone where mainly you need steel and only enough concrete to hold that steel. So the remaining concrete which we end up pouring in the lower part, in the lower 2.5 inches, which is a tensile stress zone, is unnecessary. So by putting a filler material in the lower part, you reduce that much concrete, and the concrete only goes in the upper part, which is the compressive stress zone. So you save concrete, and by saving concrete, you reduce the dead weight of the slab. And once you reduce the dead weight of the slab, you also therefore need lesser steel. So overall, lesser material, stronger slab, the steel use is lesser. It is lesser embodied energy, and because of that filler material, the heat intake is also lesser. Yes, many of the projects, the foundation is made up of RR masonry, except for the Baroda one, where it is a typical RCC framed foundation because of black cotton soil. The bracket sections are made up of timber, except for one project where we had to have steel columns in the center to carry a water tank above. These buildings are constructed all over the country, mainly in Maharashtra, but also in Gujarat, Madhya Pradesh, and Goa. Yes, you can do this work with a locally available red earth brick. Thickness of load bearing wall, if it is framed building, then you can have it even as less as 4.5 inches. But if it's a load bearing building, then depending on how tall the building is, your ground floor would be 35 centimeter and above will be 23 centimeters thick. But if you, there is a lot of engineering you can do within it and reduce the wall thicknesses further also by reducing the effective height of the wall. If you reduce effective height of the wall by putting horizontal ties, you can really reduce the thickness of the brickwork. There is, well, a question on the process of preparing lime mortar for pointing and plastering. It is a very long process. I suggest you do some research on that, but you can mail me also. My email ID has been shown, so I can share the links with you. And it's a fairly elaborate process, but not too difficult, and we absolutely do it on site. So what is the cost of timber to make the house? So I will answer this in parts. I do not use any teak wood, which is the very expensive wood to make the house. I only use secondary timbers, for which we have done a fair bit of research in the local vernacular traditions of building. So say I'll give you an example. So if teak wood is costing around 3 to 4 thousand rupees a cubic foot, we use secondary timbers which are only say 10% lesser in strength than teak. I'm specifically talking about a wood called ain in Maharashtra, just for an example. It is from the Terminalia species. And if teak costs say 3 to 4 thousand rupees per cubic foot, this ain wood only costs around 1,000 to 1,100 rupees per cubic foot. That is how the cost of the house becomes competitive to the RCC houses. So houses we built are only cheaper than the conventional RCC houses, if not equal. Well, there are a lot of reference books for vernacular construction. Please refer to Laurie Baker's manuals. You will find it on Costford's website, COSTFORD. There you will find these publications free of cost, because Laurie Baker believed that there is no copyright on these books. There are a lot of other authors. For example, there is Gernot Minke, GERNOT there are a lot of other books. I'm sure I can't list all of them here, but if you research online, you will find them. Yes, we have used in the sloping roofs at the valleys, we have used metal sheets to be able to collect the rainwater from the tiles and to slide down from that valleys. So all the interiors are, so we painted them only with lime to avoid VOCs given out of your typical synthetic paints. We have plastered the walls in lime. We have painted it with lime. We have only painted all the timber with linseed oil, so there is no synthetic material there also. So we really make sure that this can be achieved. These will be the last few questions. And you could later ask the other further questions. If I cannot answer all, you can please write them on my email and I'll be very happy to answer. So, can a house be constructed fully of wood? Yes, it can. Many houses all over the world are. Yes, this type of construction is more efficient than the conventional construction for low-rise buildings. The evidence is many earthquakes all over the world. RCC buildings have failed and traditional buildings using wood as framed material have survived. And this is all over the world, not just in India. So there is a question about the seismic result I just mentioned. The technique for the seismic results of framed buildings. This technique is called Dhajji in North India, or it is called brick knocked construction, where buildings are lasting for more than 100 years. And in up north further, it is called Himis construction in areas like Turkey. So a good question is the mud mortar house, does it have the same lifespan and strength as that of concrete and cement? A concrete building will not be certified for more than 65 to 75 years, because your RCC, the steel part of your RCC, will start rusting. Beyond that, the repairs are going to be too expensive and you'll only prolong it for a few years. But the mud walls, mud building with wood will never corrode. It is not going to rust. So it will last for at least 100 or 150 years. So concrete building is 65 years and mud and wood building is more than 100 years. So I think I have answered most of these questions. One question I would like to answer is how many trees have been cut to make a house? Is that trees are the most, or wood is the most sustainable material to use to make a house, because if you use steel or aluminum, you will first have to cut the forest down to quarry all the iron ore from below the forest, and that forest is not going to grow back soon. Besides, if I use wood, I can plant a tree again. But I would like to know whether if I use steel or aluminum, can you plant steel or aluminum again? I think that should be the last question I'm going to take. Thank you.
Right, great. So what I'll do, there are a lot of questions. I'll send you the list.
Yeah, please.
So you can reply to them, all these
Yeah.
questions. I think it was a very good session. A lot of questions, a lot of